Here we go, lesson 19. And in here, and we're going to talk about comparing intermolecular forces between two molecules. So what I'm going to do here is, well, let's just follow up what the question says. So determine which of the following has a higher boiling point. Draw a Lewis diagram, determine the polarity, the strongest intermolecular force, and the London forces. So we're going to put all that together and compare the two. And we've got which one's a higher boiling point? Methanol, better known as formaldehyde, or ethane, C2H6, which you guys will be learning about in next unit. All right, well, let's start with the Lewis diagram. So methanol, CH2O, and ethane, C2H6. So let's start with methanol. Carbon goes to the middle. It's got 4 bonds to create its octet, and oxygen's going to have a couple of electrons there to give its octet. And here's ethane. So 1 carbon-carbon bond, single bond, and we've got single bonds to each of the hydrogens. Now, this is in 3D. This is, you can see the first one here is an AX3 molecule. So it's trigonal planar. So this is a flat molecule. So this one's electrons are going to move up towards the carbon very slightly. So electronegativity value of 2.1 and 2.5. So a slight pull, but a bigger one right over here. This is 2.5 to 3.5. So yes, we're going to have definitely a negative charge on the oxygen and positive charge on the hydrogen. So this is going to be a polar molecule. So we've got polar right over here. Now, both of those carbons there are going to be AX4, which makes them tetrahedral. So that bond angle 109.5. So these are not flat, all right? So you can see that this guy is maybe moving towards us, and this guy here is receding away from us, and same thing here. This guy is receding away from us, and this guy is coming out towards us. So again, a very small dipole again, 2.5 and 2.1, but they're all going to be sort of heading in towards the carbon. And this, of course, is carbon-carbon has no bonds, no polarity. So these are all going to be collapsing in towards the carbon. The net direction is 0, all right? So it's hydrocarbons, they're going to be 0, all right? There's no electron withdrawing group there. Everything just collapses in towards the carbon. This is going to be non-polar. Okay, so now let's look at our intermolecular forces. So polar molecule, this is going to be a dipole-dipole force. And this is non-polar, so this will only have a London force. This, of course, has a London force as well. Not as pronounced as the dipole-dipole, but London force nonetheless. Well, let's compare these London forces. It's got 12 on the 2 carbons plus the 6 around the outside. So this is going to have about 18 electrons. And this is going to have 2 here and 6 and 8. This is going to have about 16 electrons. So maybe a slight advantage for the ethane, but the dipole is definitely a stronger intermolecular force than the London force. So we're going to go with the stronger intermolecular force here. So London force is approximately equal, but the dipole would be a little bit stickier between the molecules than the ethane. All right, so less sticky, just those non-permanent fluctuating dipoles. So what I've left for you here is got a whole lot of problems right over here. And don't cheat and go ahead, but I do have a sheet with just the answers and a brief explanation. So do the same thing over there. So draw the Lewis, determine the polarity, what is the major intermolecular force, and then compare those those London forces as well. This is what those questions don't do, all right? And because it's not really fair, like I'm not going to give you a problem that has, well, this is, here you go. So CH3, CH2, CH2OH. It's called 1-propanol. So it is an alcohol. It's an OH group. So it's got hydrogen bonding. Compare that to something which has, let's say it's hexane. So 6 carbons in a row. To me, this would be an unfair comparison. Why? Well, the hexane's got greater London forces, but the smaller 1-propanol has got the higher intermolecular force. So you're sort of with competing, you're with competing forces there. All right, one's higher on one scale, one's higher on the other scale. Right. So I tend to avoid those in these examples right here. So give those a whirl and see how it goes.